generics. By using these generics, you can resolve all your problems now. You can resolve all your problems. How, sir? Which one is easy actually? Writing one method or multiple methods, sir? One method. But you want type safety. Yes or not? Okay. Look, guys. When you're defining a method, here you can use a placeholder like this. You can use a placeholder like this. Look at T. T means type. Indicates type. And come here, and here you say TA TB. TA TB. What is T, sir? T is a type. Which type? That is what you should tell when you are calling the method. That is what you should tell when you are calling the method. I want this method for comparing to integers. For comparing to integers. When you are calling the method, tell the type as int now. I want to use this method for comparing two booleans. Bool now. I want to use this method for comparing two doubles. I want to use this method to compare two strings. You have written one method or four methods, huh? Louder. But guys, read it. You have written one method only here, but working like four separate methods now. Tomorrow if I pass GYD, it will take GYD here, GYD. If I pass date time, it will take date time here, date time B. If I pass customer, it will take customer here, customer B. Did you catch my point or not? Understood how is it working? That is how basically this is going to work internally. So this is what we call as generics. So now you don't have the pain of writing multiple methods here. How many methods did you write? One. Is the type safety achieved? Type safety achieved or not? Yes, type safety is achieved. Check if you want. Error. Error. Why? You can compare two integers, not integer and a double. You can compare two doubles. You can compare two integers. You can compare two booleans. You can compare two strings, but not a integer and a double or a boolean and a string. So type safe or not? Type safe. And now also writing only one method. Tomorrow, if I want one type for the first parameter, another type for the second parameter. Suppose you want one type for first parameter and one type for second parameter. Then you can say did you understand? When you are passing now, you can pass two things now. I can say int comma double means first parameter should be integer type, second parameter should be double type. Understood or not? Like this, you can just use it. This is called generics. Okay. One more example I'll show you. Just like generic method, I'm writing a class called generic class. Here I written here generic methods. Here I written here generic class. In this here, I want to write a method. A simple method like this. But this method can be used for adding only two integers. I cannot use for adding two floats, two doubles, two longs, two decimals. It doesn't work. If you want to make it work for all, can I use generics or not? What do you do? Now suppose T is double. T is a double. Now it is double A double T. So retinal type also will be double only. Watch it. The run type is also T. Array, run type is also T, yaar. So now if you pass double, how do you read? Public double add double A double B. If you pass float, public float add float A float B. If you pass decimal, public decimal add decimal A decimal B. Okay now? But that A plus B is giving an error. A plus B is giving an error. You know this error here. You read this error earlier. Last line. We cannot use a plus operator between two T's. Array, you cannot use a plus operator between two T's. That's what it is telling you. Operator plus cannot be applied. Array, one day when we tried to use plus between two matrices, we got this error. When we tried to use minus between two strings, we got this error. Do you remember or not? We learned about this already earlier. When I used the plus between two matrices, when I used the minus between two strings, we came across this error. There is the same error which is coming to you right now here. Okay now? Okay. So basically, why you're getting this error at the time of compilation, T is not known. What is the compiler thinking? You know, T is a type. Are you saying string is a type now? When you say T A T B, the compiler thinking T is a type. But you don't need to selling operands of type T and T. T is a type it's thinking. And telling you, I did not find any method for using plus between two T's now. Yes or not? But T is a type which we come to know in the runtime, not in the compilation time. But right now, compiler wants to know that. What is it? How can we use a plus between two integers? You want to, but actually you come to know T in the runtime. You know, you come to know in the runtime, compiler is not compiling this code now. How to skip it? To skip it, you're required to shift this type resolution to runtime. You need to skip the type resolution to runtime. How? You know, guys. Like this. Remember dynamic? I'm not getting a response. Dynamic, it is just like there. But here type identification is done in the runtime. Type identification is done in the runtime. When I use B1 plus B2, error is not coming. Why you know? It will identify in the runtime. Until then, it will not bother. Anyhow, in the runtime, we'll specify what is the type now. Understood? If I don't use a dynamic, type identification is performed in the compile time. Compiler won't allow the compiler to compile this. So what should I do? I need to shift it to runtime. Don't bother about it now. I will tell you about this in the runtime. Did you catch my point or not? What is that? Don't bother about it right now. I will tell about this in the runtime. And telling ignore this now, and we will find out in the runtime. How to tell that? Dynamic. By using the dynamic, we are going to do this. Is that clear, all of you? Okay, like this, I want to write multiple methods in my code. Subtract. Multiply. Divide. Okay. Now, how many methods I have? 4 methods. I just have 4 methods in the class. So every method when I'm calling, I need to specify the type name here. You want to use it on integer, or you want to use it on double, or you want to use it on a string. You need to tell the type name there now. Am I right or not? Okay, you need to tell whether it is an integer or a long or a byte or a decimal or a double or a float, whatever it is, you need to tell. How many times? 4 times. Without telling 4 times here, you can do like this. What do you know? I remove the T for all the 4. So all 4 are giving error. T is undefined. You can directly use a T here. Did you understand? Earlier you specified the T while calling the method now. Now specify the T while creating the instance of the class. Now all the methods in the class will use that as its type now. See here? Generic class, or otherwise I'll name this class as math class here, not generic, math class. Okay. Math of int mi is equals to new math of int mi dot. See, changing of C. Same way, math of double md is equals to new math of double. Are you clear? Same if you create an instance by float. Are you clearer or not? Like this, we are just going to have, we're going to use it. So this is called as generic class. The previous one is a generic method and is a generic class. Are you clear? So when this generic is introduced at 2.0, okay? When they introduced the generics in 2.0, at the same time, guys, they also re-implemented all the existing collections